Hi, today we're looking at PAT paper from 2015 and going through question 14. So in question 14 we're asked to write an equation relating the angle of incidence θ1, the angle of refraction θ2, the refractive index of the first material and the refractive index of the second material for a ray of light travelling from material 1 to material 2. We're asked to sketch a diagram of this situation and are asked under what conditions and for what θ1 is the ray of light completely reflected. Let's address the first part. This should really spring to mind straight away, and it's something called Snell's law. What this says is that the refractive index of material 1, N1, times the sine of the angle of incidence is equal to the refractive index of the second material times the sine of the θ2. Now for a sketch. Well, how we do this is we draw the interface. So this is the boundary of the two materials. So you have material 1 at the bottom here, and material 2. So we label it with refractive index N1 and refractive index N2. And we draw a normal, a line perpendicular to the interface. So we have our incident ray here, and remember that all angles are measured relative to this normal. So this is θ1. And then it will refract into this. So it's going to come off at some new angle, depending on the value of N2. It'll be towards or away from the normal, but we're arbitrarily drawing it going away. And this angle here will be our θ2. So now for the third part, it says under what conditions and what θ1 is the ray reflected completely? Well, this means under what conditions and from what angle of incidence will there be something called total internal reflection. So when will the ray come along, strike the interface, and travel completely along the interface? It won't refract into the second material at all. Well, for this to happen, we require that the second material 2, is less dense than material 1. So this means we require N2 to be less than N1. We also require a condition on the angle of incidence, θ1. So we'll call the angle of incidence for which it's happened, θc, the critical angle. So that means we have N1 sine of θc equals N2 from our formula up here. And, well, θ2, you see, is going to travel along here. So now we have that the angle θ2 is in fact 90 degrees. So we have sine of 90, which is just 1. So we have that N1 sine θ1 times sine θc is in fact only equal to N2. So this gives us our condition. We're told that θc must be equal to the inverse sine of N2 over N1. So here's our first condition, and here's the angle we require. And that's the end of the question.